We will now solve rational exponent equations, or equations with rational exponents. So if we have x to the m over n equaling some number k, we are going to first make sure we isolate the rational exponent, because essentially we have a radical when we have rational exponents. Then we raise both sides, or use the power rule, by n over m, by the reciprocal, and then we're going to check our answers, because sometimes we get false answers. Now, this is for my college algebra students. There's also a little rule here about the denominator being even, and of course an even radical with a negative under the radical, it doesn't work. But we're going to exclude that and just go on with what we're going to be solving for. So x to the 3 seconds equals 27. So we're going to multiply by 2/3 to both sides, because that will create a x to the first power. This one, this is when this rule comes in very handy, because we are going to cube root 27 and then take that to the second power. So cube root of 27 is 3. Square 3, we get 9. Okay, you can plug that back in and take the square root of 9 and cube 3 to get the 27. So x plus 5 to the 2/3 power equals 4. We are going to raise both sides to the reciprocal power, because 2/3 times 3/2 gives us 1. Now this is square root of 4 to the 3rd power. Remember, the denominator is the index. So x plus 5 equals 2 to the 3rd power, which is 8. So x equals 3 in this case. X minus 6 to the 1/2 power equals 4. So we are going to square both sides. So x minus 6 equals 16. So essentially this is like saying square root of x minus 6. So we're going to square both sides, because essentially we're doing the same thing as if these were radicals. -3 plus 8 minus 2x of 5/4 equals 29. Now here we are not isolated, so we are going to add 3 over so that our power is isolated. So anytime you have weird, I will call these weird equations, whether you have squares or radicals, absolute value, your rational exponents, you're going to isolate them on one side so that you can use a power rule or whatever rule you need to work the problem. We're going to raise this to 4/5 power. So 8 minus 2x equals the 5th root of 32 to the 4th power. A lot easier to root it than power it, instead of taking 32 to the 4th power and then trying to take the 5th root of that. That would be a nightmare. 5th root of 32 is 2. 2 to the 4th power is 16. square root, that would be -4. Okay, now, if it's negative, I really want to make sure that whatever we have up here is positive, because the fourth root of a negative number will not work. So if we plug -4 into here, we'll have -2, actually up here, -2 times -4, which is a +8. So 8 plus 8 is 16. So that square root of, or that fourth root can root that 16. So we're good on that. The only thing that you have to really watch out for these is if whatever you are rooting or whatever you have under the radical, which would be in the denominator, as long as whatever you have here is not negative when your denominator is a even number, you should be fine. If it's an odd number, third root of -8, you get -2. So it's that positive negative roots. Let's see here. Ooh, this one's a good one. And then this one will be the last one. Okay, and that's to the power. So we need to isolate this little guy right here. Okay, we can even put him in parentheses and say we need to isolate only that guy. So subtract the 6 over. Divide by -2. 27. Okay, now we're going to take each side by the power of 2/3, so that we get x equals cubed root of 27 to the second power, which would be 3 to the second power, which then would turn into a 9. This will conclude this video.